Hello and welcome, you cool cats, back to another episode of SIP Zoyus, where we have cat scratch fever for mathematics. Alright, let's go ahead and dig into our topic for the day, focus and directrix, right? Let's focus on the focus and directrix. So, these are going to be actually two quintessential aspects, or should I say features, of our parabola. These are actually going to define ultimately what makes up a parabola. And if you want to explore more into this, I definitely encourage you to check out our extension. It's going to be a really fun exploration of how to come up with the equation for a parabola with these two items. So with that said, let's go ahead and talk a little bit about this. So the focus and directrix are defining aspects of a parabola, right? Defining, that means that this is where we get our parabola from. Realize we are getting the origins or the roots of a parabola. Not roots as in when y equals 0, but roots as in the place where it comes from, right? So in definition, a parabola is a set of all points which are equidistant from the focus, a fixed point, and the directrix, a fixed line, right? And in case you're not sure, equidistant, just a fancy word for equal distant. And so what this is saying is that how we get a parabola is we go ahead and we pick a point, right? We pick a point, we call that the focus. And then we pick a line away from our point called the directrix. And it just so happens to be coincidentally, right? Coincidentally, right? Like these things describe the way things fall. These things are used in headlights. These things are used in sonar dishes, right? Coincidentally, it happens to be that when we pick this point in this line, that all the points that are an equal distance away from the line and the point happen to make up a parabola. Okay, and let's go ahead and just like visually explore this, right? Realize that here we have an example where we picked a point on our parabola and compared it to the distance from the focus and the distance from our directrix. Of course, side note, we always want to go perpendicular when making that distance from the directrix. And look at it, it just so happens to perfectly equal each other. Right? Weird. It's a little bit spooky. I'm going to be honest with you guys, I get goosebumps just talking about this. It's crazy. It's borderline magical. Okay? And again, if you want to find out more about this and dig into it and really prove it to yourself that this is what happens, go ahead, check out that extension. It's going to be very worth it. So with that said, right, these are the things in which we can create parabolas, right? We give life to parabolas with these. It defines what it means to be a parabola, having equal distance from here to here and here to here. At any point, right? And let's go ahead, let's pick another point just to really verify that, right? From there to there and there to there. Whoa. Same distance, bro. Whoa, man. It's crazy. Okay. So, sorry, that's like, my father's a baby boomer, and he was born in 62, so a little bit of that kind of like hippie gene made its way into me. So, for a parabola at the origin, so just kind of taking the simple case of it, the focus and directrix are distance p away from the vertex, as seen in the diagram. Now, let's go ahead, and I want you to ask, why is this, right? Think about why this needs to be the case. Why this needs to be the case is because we are finding the set of points which is equidistant, right? Equal distance from our focus and our directrix. Meaning that when we find our vertex, it needs to be precisely p away from both of these. Precisely distance p away from the directrix, precisely distance p away from the focus. This is the only way it can happen, right? We made a definition. If we did not have that happening, we would not meet our definition. Okay? So, when the vertex of the parabola is fixed at the origin, the equation of the parabola then must take this form. Okay, it needs to take this form, and we're actually going to go ahead and call this parabola form. Not the most eloquent name, but it communicates the purpose, and really what this is used for is finding the vertex and the directrix, right? Both of which we're going to have this format on the test that we take, but you do, of course, want to commit this to memory. And just side note with a little bit of asterisks, if we want to talk about horizontal parabolas, not going to do it in this video, but in the future, this format's going to look like this. Notice we just switched x and y because they are technically inverses. They are inverses. Everything's about them is an inverse. So, right, where it takes the form x squared equals 4py, where p is that distance from the vertex to the directrix slash focus, right? It's the same distance away, it doesn't matter which one you consider. Right? So thus, now, right, we started with the case of the origin. Now let's go ahead and expand our mind to something that's maybe moved from the origin, maybe shifted from the origin. It's going to look like this. It's going to be quantity x minus h squared equals 4p quantity y minus k. And the reason for this is it's just saying that, hey, if we need to adjust this from the origin, we just need to account for it when we plug in our x and y. And how we account for it is just with these modifiers, these variables h and k. And of course, right, like we're used to, how we find the vertex by zeroing these things out. That's going to mean that positive k is our y value for the vertex, right there. And positive h is our x value for our vertex right there. Okay. And let's actually go ahead and box this guy in because he is super important. He is really important. We need this guy. So, is the general form for a parabola, right? Okay. And another little asterisk right here. Realize, we can switch our y and our x, of course, with our h and our k respectively. And when we do this, that's going to then give us the horizontal parabola that we see down here. Again, we'll work with it. Just for right now, we're going to keep it simple with these two examples. So, moving on at an awesome pace, we have our first question. Find the focus, find the directrix of quadratic blank. Right? So what's the question asking? It's asking for us to find the focus and asking for us to find the quadratic. So let's go ahead and do that. Find the quadratic. We're given the quadratic. What am I talking about? We're looking for the focus and the directrix. So let's go ahead and do this. So I have some steps over here to help guide us. I do emphasize that you don't memorize these, right? Math isn't about memorizing these things. It's about making a intuitive process, right? Understanding some key definitions and then being able to run with that logic. So these are here, and I definitely want you to use these to help get you off the ground, but after a while we should start internalizing these. And we don't need to write them out. We're just going to internally go through these when we find them. So step one, we want to go ahead and get this equation into parabola format or directrix focus format. The reason for this is because really what we're interested in finding is this p value right here, right? We find p, we know that then our focus will be that distance p away from our vertex, as well as our directrix, which is that distance p away from our vertex. Okay? So we're really interested in that p, and so how we can find it when we're given an equation is we can then go ahead and get this in format, which, look at that, it already is. Thank you, Mr. Zoyas. It's very kind of you. And we can then go ahead and set for p and whatever is in front of the y multiplier, or in this case our linear term, right, because y is technically our linear term, that's a power of 1 to it. We're going to set that equal to 4p because we know that we got to get a 4p out there at some point. So let's go ahead and just so we can see that visual comparison, 4p times y minus k and x minus h squared. Right? And just, comparing the two, right, we can see that associates with that, that associates with that, that associates with that, right? It needs to, it's in the same format. So we can first go ahead and say that our vertex is h comma k, right? Our h is going to be 1. Our k is going to be 6. Okay, so there's our vertex. Now let's go ahead and figure out what this p value is going to be, because remember that p tells us then how far the focus is and how far the directrix is. So finding that, we're going to make a logical statement. We're going to realize that, hey, we have 1/2 over here and we have 4p over here. These guys need to equal each other, right? This needs to get to 1/2, so I'm curious, what does p need to be to get this to 1/2? So we're going to go ahead and we are going to set 1/2 equal to 4p, right? Because we know that this needs to be that. So we set them equal. Now we have a beautiful equation that we can go ahead and solve. So we'll begin solving this, and it's almost like just, I don't know, like intuition, like it just kicks in, right? Just go ahead and solve it. Divide both sides by 4, so 1/2 divided by 4, that is going to be 1/8. If you have questions on that, definitely okay. But realize that's just fractional work. That's a whole different topic which we can work on. But right, if that part trips you up, don't worry too much. It's okay, right? Don't hit the big red button. Save the big red button for true panic mode. And we never panic because we have nerves of steel. So 1/8 equals p. And right, so now we found this distance, and that really just unlocks the whole problem. That busts it wide open. And side note, that was step 2 and 3. Right, set those two equal to each other, and then solve for p. We do that, and now we can go ahead and now find our directrix and focus. Because remember, it's just going to be that distance p away from our vertex. Okay, so when we're dealing with a vertical parabola, right, one that opens up and down, realize that we're just going to be adding and subtracting this distance p onto our y value from the vertex, right? It's got to go that distance up and that distance down. So we can go ahead and find the focus by doing that distance up. So we're going to have 1/6 and then up 1/8. Okay, so so having the vertex of 1/6 and then up 1/8, right? Of course, that's our y value, so we want to do 1,6 plus 1/8, and that's going to equal 1, and then that can be 6 times 8 divided by 8. 6 times 8 is 42. So, or 42, sorry. 48. 48 plus 1 is 49. Divided by 8. Cool. That's our focus. And realize I just went ahead and I just got this into an improper fraction. I just think it's a little bit preferred for this. Okay, so that's our focus. That's our focus right there. Right? Job number 1 done. Okay, now time for job number 2, the directrix. Okay, now realize our directrix is going to be a horizontal line. When we have a horizontal line, that means it's going to be y set equal to a number. Because remember, right, when we have a horizontal line, that means y can only be one value. It can't go up or down. It's fixed to this value, so we have y equals a certain number. So we want to find out what that number is, and realize it's just going to be down p from our vertex. Okay, so again, our vertex is over here. So we start at 1,6, and then we go down 1/8. And now there's really no good, I don't know of a good way to kind of write this, so I'm just writing this out so we can kind of see what the step is. Okay. So again, we're going down 1/8. So from our y value, we're going to take away 1/8. So that'll be 1,6 minus 1/8. And again, doing that math really quickly with the fractions in the head. 6 times 8 divided by 8. 6 times 8 is 48 divided by 8. So that's going to be 48 minus 1 is 47 divided by 8. And I'll actually be completely honest. I'll go ahead and share something with you guys. Talking this out, saying the math out loud, ups your math game so much. Like, to be honest, I couldn't do calculations like this in my head just because I had calculators and we did physics, and we never had weird numbers like that. We did physics, right? Physics has pretty nice numbers for the most part. So I never used to be able to do that, but talking it out loud and kind of making that oral totally worked. Total game changer. Highly recommend it. Okay, so we just found our directrix, we just found our focus. So now our focus is a point, and actually I just realized kind of one mistake that I made. Our directrix, is it a point or is it a line? Right, our directrix is a line. So we did find this y value for it right here, but realize our directrix is going to be y equals 47/8. Okay. And this is our true directrix. Sorry, I put it in imposter directrix over to the side. I'm sorry. Please forgive me. Please forgive me. I made a mistake. That's actually our real directrix, because our directrix is a horizontal line. But realize, right, that point would lie on that line. And maybe you can think about it like that, right? Like first I find the point, then I find the line. Okay. Example number 2. And side note, realize, right, we just hit the 15-minute mark. We would be done, but there's another example, another way this problem can be delivered to you. And I want to make sure that we see it this way too before coming into class. So find the equation of a quadratic with focus 8, negative 15 divided by 16, and directrix y equals negative 17 divided by 16. Okay, right, so what are we given here, and what are we asked to do? So we're given the focus, we're given the directrix, and we're asked to find the quadratic with this, right? So they want us to find the equation of it. Now, what I highly recommend doing is going ahead and drawing these on your graph. Right, take your directrix, sketch that out, take your focus, and sketch that out. This is going to help you just orient yourself for the whole problem. You don't technically need to do it, but it's just, it gives you direction. Okay, so we're going to go ahead, y equals negative 17 over 16. Well, that's pretty much like negative 1, but it's just a little bit lower. So I'll go right below negative 1, and just draw that right there. Picking up an Australian accent. No, it's actually a really bad Australian accent. If you're listening and you're Australian, I'm sorry. I think I might have just insulted you. That's going to be our directrix. We can actually go ahead and label that too. And then we're also going to go ahead and plot our focus, which will be over 8. So over 8. And then up or down, negative 15. Negative 15 divided by 16. So over 8, down negative 15 divided by 16, that's just a hair above negative 1. So I'll go ahead and put that point like right there. Okay, and so realize, right, looking back up at our diagram, our parabola fits right between the two. It goes right between it. Remember, it's equidistant between our focus and our directrix. So we want to go ahead and just squeeze in a little parabola in between here. That actually has a little bit too much bend to it, but that's okay. You get the idea, right? It's going to look like that right between there, right? That's our focus. That's our directrix. It's very tiny, very close to each other. Okay, so we do that. That gives us the orientation where we can now start thinking about this. So step 1, find the vertex using the focus and directrix. Okay, so we want to find our vertex. We find our vertex. We can go ahead and start writing our equation for our quadratic. Okay, so let's first find our vertex. Now remember, where's the vertex in context to the focus and the directrix? Right, again, where is it in context? It's halfway between it. It's going to be the midpoint, technically, between this line and this focus. So let's go ahead and just find that midpoint between the two. Right, so we have 8, negative 15 divided by 16, and a line that is negative 17 divided by 16. Now, you may be able to just look at this and realize, like, okay, I'm looking for the point that's halfway between the two, right, in the y direction because it's opening up and down, and just see that negative 15 and negative 17, well, halfway between that is negative 16. And so our vertex would then need to be, as far as our y is concerned, negative 16 over 16, because, right, negative 16 would be halfway between our negative 15 and our negative 17. And what is our x value? Well, of course, it's the same as our focus. Realize that the focus goes up, not over. Okay, and so you could just realize that that's our vertex. Now, say that's difficult and you want a more analytical approach to it, what you can go ahead and do is you can find the average of these y coordinates. Okay? So the average of y, right, we're going to have negative 15 divided by 8 plus negative 17 divided by, oh, where did I get, I'm sorry, that's not supposed to be 8, that's supposed to be 16. You guys are probably yelling at the monitor right now. It's okay, calm down, your parents are looking, you're making a scene, it's alright. There you go. Alright, we're all calm again. Divided by 2. Okay, and again, we're just finding the average of this, right? Negative 15 divided by 16, negative 17 divided by 16, and divided by 2, right? We add those together, divide them by 2, that's how we find the average of something. Add them all up, then divided by the number of things we added. So that's going to be negative 32 divided by 16 divided by 2. Okay? And that is going to equal, so this 2 is actually just going to multiply with that 16. That's kind of how our division works. Again, if you need work on that, that's okay, but realize it's a separate topic. Negative 32 divided by negative 32, which is indeed negative 1. And look at that, that's actually what our vertex reduces to. Our vertex is going to turn into 8, comma, negative 1. Okay, so we found our vertex. Now realize, in finding our vertex, we actually found the majority of this problem. Okay? And what we're going to do, so we find our vertex, this is where we can go back to our ultra special parabola format with the very uncreative name, and go ahead and plug in our vertex to here. Right? Use this to fill out our general format. So our general format is going to look like x minus h quantity, oh, you can't see me, now you can see me, x minus h quantity squared equals 4p quantity y minus k, just like that. We know that it's hk with our vertex, that's how it's denoted, right? So we have an 8, and of course this is the x value it associates with our x, so it's going to be x minus 8 squared equals 4p. We don't know what p is yet, but that's okay. We are going to solve it. Trust me, we will solve it. And we will have y minus k, and we know that k is going to be negative 1. So you don't want to forget about that negative when you plug it in there. So that's actually going to turn out to be a positive 1. We can change that later, but for right now, right, we plugged in those things, but there's one thing missing, right? What's the one guy in here who we want to know that we don't know? You, sir. You over there in the corner. We want to get to know you. We want to get to figure out what p is, right? And realize this goes right in line with our steps. We found the vertex, we substituted it into our parabola equation, and then step 3 is going to be find p using the vertex and the focus. Right? So realize we can now find p because we have our vertex, our focus, and our directrix. And so if we know that our vertex is 8, comma, negative 1, and our focus is then 8, comma, negative 15 divided by 16, we can subtract these 2 points to find out what p is going to be. Right? So we can do our focus minus our vertex. So focus minus vertex. And that's going to be a focus of 8, comma, negative 15 divided by 16 minus 8, comma, negative 1. Okay? Now let's go ahead and do that math. So 8 minus 8, well, that's just going to equal 0. And then negative 15 divided by 6, or negative 15 divided by 16 minus a negative 1, so the negative is going to be a positive. So negative 15 plus 16 plus 1 is going to give us 1/16. And that is our p distance, right? This is what p is, right? Equals p. Okay? And our distance p, we can think of that as a point, and actually, God, I'm sorry, it's going to get so messy. 0, parentheses 0, comma p, right? And so p is 1/16. So now we realize what p is, right? We just found p. Hey guy, we found you. Let's go ahead and now take this and plug it back in. All right. So let's go ahead and go over here with this. So we have x minus 8 squared equals 4, and p, we know p, right? P is 1/16. 1/16 is what p is. And y minus a negative plus 1. Alright, let's go ahead and simplify this term right here. So we have x squared minus 8, oh, I'm sorry, x minus 8 squared. Squared's on the outside. Equals 4 divided by 16 is 1/4. Y plus 1. Why? I don't know. Okay, that was really bad. But yeah, so that's our equation right there, right? Right, we found P, we substituted it back in, and we got our equation. Okay,